Telecom Hyperscale Data Centers for Dummies by José-Alonso Hurtado González. Purpose. This guide explains how a Division 27 Telecommunications Hyperscale Data Center progresses from an empty building to an owner-approved facility that has been fully installed, tested/validated, commissioned, accepted, and is ready for operations. It is based on real-world hyperscale data center projects. While every owner, end user, client has its own standards, specifications, and acceptance criteria, the overall construction, validation, and turnover process is generally similar. No subphases will be in order. This guide assumes all prerequisite building systems are operational and approved, including electrical power has been fully tested, commissioned, and approved for energization. Chiller systems are operational and maintaining the required design temperatures. Rack cooling systems are fully operational and performing within project specifications. This guide focuses exclusively on Division 27, Telecommunications. It does not cover the installation, testing, commissioning, or turnover of electrical, mechanical, plumbing, MEP, fire protection, or other CSI divisions, except where they directly impact Division 27 readiness and telecommunications operations. Phase 1. Design. Nothing is installed yet. The owner and engineers determine what equipment will be installed. OSE/rack/cabinet layouts, fiber routes, copper routes, network architecture, GPU requirements, power requirements, redundancy, capacity. Deliverables include IFC drawings, shop drawings, specifications, network design, fiber matrix, rack elevations. Phase 2, procurement. Nothing can be built until materials arrive. Typical materials include OC enclosed, racks open, cabinets enclosed, fiber trunks single mode, MPO trunks single mode, fiber jumpers single mode, fiber cassettes, patch panels, if for fiber, also known as rack mount LIUs, cable trays, basket trays, ladder rack, switches, routers, NVS switches, GPUs, optics, labels. Phase 3, infrastructure installation. The building starts taking shape. Teams install ladder rack, basket tray, cable tray, telecommunications pathways, OSE's racks, cabinets, fiber backbone, copper backbone, Category 6A, Category 8, or project specific. Grounding and bonding infrastructure. Goal, everything physically installed and ready for cable installation. Phase 4, fiber installation. This is usually one of the largest phases. Crews install 6912 count fiber, 3456 count fiber, 288 count fiber, 104 count fiber, 72 count fiber, 48 count fiber, 24 count fiber, 12 count fiber, other count fiber, then ribbon splicing, fusion splicing, other type, fiber routing, dressing, labeling. Phase 5, rack installation. Each rack is installed according to drawings. Typical work, position rack, anchor rack, ground rack. Install patch panels, if for fiber, also known as rack mount LIUs. Install cassettes. Install cable management. Install equipment. Keep in mind that in most hyperscale data center projects, OSE/rack/cabinet assemblies arrive on site fully integrated and pre-configured, rack and stack, requiring only placement, then to interconnection, validate, test, commission. Phase 5A, copper infrastructure installation. While fiber carries the majority of hyperscale network traffic, structured copper infrastructure remains critical for management, auxiliary, and project-specific network connectivity. Crews install copper backbone, if applicable. Horizontal copper cabling. Category 6A cabling. Category 8 cabling, where specified. Copper patch panels. RJ45 outlets and terminations, if applicable. Patch cords. Cable management. Labeling. Routing and dressing. Typical applications include management networks, out-of-band OOB management, BMCI ILO iDRAC connectivity, console connections, auxiliary Ethernet, temporary commissioning networks, other owner-specific copper infrastructure. Phase 6, fiber and copper termination. Now crews begin connecting everything. Fiber, MPO installation, LC installation, fiber patch cords, single, shuffle, Y cables, and other fiber patch cable types. Trunk connections. Cross-connect between OSER racks/cabinets to OSER racks/cabinets. Port verification. Copper. Category 6A termination. Category 8 termination. Copper patch panel termination. RJ45 terminations. Copper patching. Horizontal patching. Backbone patching. Port verification. Phase 7, fiber dressing, one of the most overlooked steps. Every cable should be routed correctly, dressed correctly, supported, protected, labeled, maintain bend radius. Poor dressing creates future failures. Phase 8, documentation. Nothing exists unless it is documented. Examples: daily reports, RFIs, submittals, red lines, as-builts, material logs, OSE rack/cabinet trackers, fiber mapping, fiber splice records, fiber patch schedules, copper backbone schedules, copper horizontal schedules, copper patch schedules, test reports. Phase 9, pre-validation, LVVS. Subcontractors inspect their own work. Typical checks, labels, fiber routing, copper routing, fiber patching, copper patching, port locations, OSER rack/cabinet numbers, equipment installation, damage, cleanliness. Goal, catch problems before validation. Phase 10, energization, critical milestone. Power is applied. Equipment begins operating. Examples: switches, routers, NVIDIA switches, GPU racks. Without energization, validation cannot continue. Phase 11, bootstrap. Engineers configure equipment. Typical tasks: IP addressing, initial software, firmware, network configuration, basic connectivity. Now equipment can communicate. Phase 12, LVV validation, the longest and most important phase. LVV verifies every fiber, every copper cable, every connection, every patch, every port, every optic, every OS, every rack, every cabinet. Typical tests: fiber, OTDR, OLTS, VFL, end-face inspection, polarity, optical light levels, patch verification, copper, fluke certification, wire map, length verification, next fixed where applicable, return loss, insertion loss, category compliance. Patch verification. Every failure generates rework. Phase 13. Burn in, burn at all. After validation, equipment operates continuously. Purpose, find failures before production. Example, bad optics, bad fibers, overheating, configuration issues, hardware failures. Phase 14, punch list. Everything still remaining is corrected. Examples, missing labels, missing jumpers, dirty connectors, broken ports, documentation errors. Phase 15, end user client owner. Inspection, the owner verifies. Construction, documentation, validation, standards, network readiness. Only approved racks move forward. Phase 16, client turnover. The owner officially accepts OSEs, racks, cabinets, network, documentation, testing, validation. Construction is complete. Operations begin. The typical OSE/rack/cabinet lifecycle. Every OSE/rack/cabinet follows nearly the same progression. 1. Installed. 2. Equipped. 3. Fiber installed. 4. Copper installed, where applicable. 5. Fiber and copper terminated. 6. Fiber and copper dressed. 7. Labeled. 8. Pre-validated. 9. Energized. 10. Bootstrap completed. 11. LVV validated. 12. Burn-in completed. 13. End-user client approved. 14. Turned over to operations. Yes, OSE are passive, and there are cabinets that are passive. Common reasons projects fall behind. From your end-user client reports, the most common recurring issues were missing materials, incorrect labeling, wrong patching, poor cable dressing, missing optics, failed validation, damaged connectors, schedule pressure, trade interference, with OSEs/racks cabinets tampered with after validation, documentation not updated, communication gaps between trades, unknown personnel modifying completed work, copper certification failures, failed fluke testing, incorrect copper backbone patching, incorrect horizontal copper patching, incorrect Category 6A, Category 8 terminations. The end-user client representative's role. An end-user client representative is not installing fiber. The end-user client representative coordinates the entire process by tracking production, identifying blockers, coordinating trades, escalating issues, supporting LV, and supporting end-user client, updating war room metrics, managing rack readiness, driving schedule recovery, communicating status to leadership. Final principle, a telecom hyperscale data center is not complete because every cable has been installed. It is complete only when every OSE, rack, cabinet, fiber path, network device, document, validation record, owner inspection, and turnover requirement has been successfully completed, independently verified, accepted by the owner and AHJ, then transferred to operations. For further information, contact José-Alonso Hurtado González.